Hi guys and welcome. In this video I'm going to initially just try to explain how all these parts which form the dial side connected to the hour wheel of the chronograph interact to operate, stop, start and reset this. Over here we have a tension spring, and this spring acts against this component here and this component here, which is the brake. The brake and the upper component both pivot on the same point, and the hour wheel of the chronograph sits next to the brake. When it's under tension from this spring, it pushes the brake onto the chronograph. When that tension is relieved, it releases the brake from the chronograph, and the chronograph wheel is driven from an extended clutch drive gear system which is fitted to the mainspring barrel, and that will then allow the hour wheel to rotate. Over here you have the hammer which resets against the heart of the chronograph wheel like so. That's the face of the hammer, and it resets. Let's just try and get that roughly into position for you without knocking everything all over. No, unsuccessfully. And it resets against the heart of the chronograph wheel, like so. Down here we've got the part that was broken, and this is the part that's actuated by the reset lever, and that sits on a pivot down here, and the face of it presses against this section here. This hammer pivots here, and this pusher, if we can try and get this in frame, pushes against this, which makes the hammer swing down like so. So when you press the start button of the chronograph, we're just going to remove the tension spring because it's obvious what that does. That just maintains tension. To press the brake, which we can also remove for the purposes of this demonstration, those two bits there press against the wheel and stop it from rotating, and that just acts as a brake against the chronograph wheel. This part here has a long extended pivot, which you can see there. And what happens with this is it is activated by a lever behind the on the back, the upper side of the movement, which operates the standard chronograph. So as you press the start button, this pushes against this long pivot here, which moves it downward slightly. It presses back against this spring, relieving the tension on the brake. So, and that locks in place because there's a bar kind of like this but underneath that pushes that way, pivoting this like so around this point because it's pressing against this bar here. That then frees up the wheel to rotate, which is driven by the extended clutch drive system on the mainspring barrel. So that then drives the hour wheel in a clockwise direction, and this records hour increments, of course. When you press the stop button, it relieves the pressure on this here. This pops back up, the brake then pops back into place and stops the hour wheel and maintains it in that position. And this is all due to the pressure from this little spring here. All these have adjustable parts, adjustable cam eccentric screws rather. So that's the stop function. When you're resetting, what you have is this hammer interacts with this slot here that you can see, and there's a little divot on it which goes into the slot, but it's the other side, it's that side essentially. And as that moves along that slot, it moves this component as well. So you press the reset button, this bit presses against here and pushes this, which pivots down like so. As it pivots down, it pushes this down slightly relieving the pressure on this spring over here and relieving the brake. So it's taking the brake off the hour-driven chronograph wheel. The hammer strikes the heart of the chronograph, resetting it to the 0 position. And then when you release the stop button, this pops back up under spring tension, releasing this and allowing the brake to grip again. So hopefully that was understandable. I'm just going to zoom back out so you can get a sort of full view of all of the components together. So zoomed out, hopefully you'll get a better picture of what's going on. So you've got this which maintains your spring tension, which keeps your brake pressed against the chronograph wheel. This sits underneath this component here. I'm just putting it on top for clarity. So this is the pivot point where the hole is, and this extended pivot here is what allows it to swing around that pivot point. When you press the start button of the chronograph, a lever on the top side of the movement, the back area where the chronograph components are for the seconds and minute recorder, presses against that, rotating it down again around the pivot, pressing back on the tension of this and releasing the brake. That holds that in place so that this wheel has the ability to turn clockwise, and it ticks round recording the hours. When you press the stop button, it releases tension on this. The spring tension then pushes it back, allowing the brake to re-engage and holds it in position. When you press the reset button, as you press this, it pushes against this bit here. This is sprung, of course. This pivots around here. The little bar on the hammer face interacts with this slot. As it slides down, it pushes this down slightly, pushes the hammer away and pushes against this spring tension, relieving the pressure. The hammer face then strikes the chronograph heart, resetting it to 0 position. As you release it, the spring tension of the W-shaped spring that sits on there pops that all back into place. So it's actually quite straightforward, and this I've done mainly as trying to explain to the owner how it worked. And I said I would try and I would lay the components out separately like this to hopefully make it a little bit clearer. So I'm removing everything else that's in the picture, as it were. So what we're going to do now is go ahead and reassemble these components. Back to the main face of the dial, and you can see we've got the hour wheel of the chronograph there. I'll be applying a very, very small amount of oil on the pivot point at the back. It doesn't need much because it doesn't rotate very much. The only thing it really needs the lubrication for there is for the reset when it snaps back to 0. If it snaps back, because of course it snaps back quite quickly, and if it moves a decent distance, it will generate a little friction, though overall it won't be excessive, so it doesn't need a huge amount of lubrication. And then the pivot points will all receive a small amount of grease accordingly, and as I said, the faces of the components that strike one another, as it were. All the components do have to be refitted in a specific order, however, for it to work properly. So I shall be going through that, refitting everything, and then we'll refit the calendar plate and test it and see if that works okay. Hopefully now that's fitted together, it gives you a bit more of an idea of how these parts interact. As you can see, this sits above this and bears onto this surface, allowing it, when it's pressed, to pivot the hammer down and reset on the heart there in this slot, which also frees up the brake. So hopefully that's a little clearer in combination with the explanation given with the parts separate. What I need to do now is refit the spring on here and the tension spring on here, at which point the calendar plate, the bit that the calendar works fit onto, and sandwich the dial side chronograph components can be fitted. Now this particular one here is a little bit fiddly to fit, so you do need to be careful and take your time. And I'm as yet undecided if it's easier to actually fit this section that hooks under first and then over the eccentric screw, which I think is the easier option because it has a little hook shape to it, which hopefully you can see there. I think that is going to give much less risk of putting the spring under unnecessary tension and breaking it, like so. Apologies if I'm obscuring the view a little, but there we go. So that's now got all the parts interacting with each other as they should. Revisiting this again, and I've removed the calendar plate, and the reason for that is while I was having a good close-up look before I went ahead and fitted the hands, I just popped a bit of lubrication on the barrel arbor jewel, and then I noticed that it actually looked as if the brake was underneath the wheel. And I think this is what had happened the first time around. I think this is why it was continuously driving. And obviously it wasn't resetting because of this being broken. And having looked at that in operation, I'll show you in a moment, you can see why it does. It must put stress on this point, but I'll show you that in just a moment. But when I took it apart, I found that the brake was actually under the wheel, and I thought that had just sort of popped under there as I'd taken it apart. It's possible it was already under there because this does allow for a little bit of up and down play, surprisingly. And I'm wondering if that's why that was driving continuously before. It may well be the case. And that's obviously why you couldn't see the brake engaging and disengaging through the gap when I was trying to show the close-up. So what I'm going to do now is try and refit this again, and hopefully this time around it will work and stay where it needs to be. You've got the start-stop pusher, which you can actually now see the brake. Now obviously you're not going to see it move a lot, but what it's doing is it's relieving. See, it's free of the wheel, the driving wheel just there, and you can see now that that turns much more easily. That would explain why that wasn't turning very easily. I thought it was just the friction. If you then press the stop, you can see that brake reapplies, and if I try and push that away, it just pops back into place, as you can, hopefully, as you can see, like so. And then likewise if I do that, and it obviously just relieves tension enough for it to move. Now when I press the reset button, you should just see that heart pop back like so. And if we move over here to where you can see the face that interacts with this pivot lever that pushes the hammer up in this little circle here. Now you can see as I press that, try and move that slowly for you so you can see, there you go. You can see there that actually encounters a considerable amount of flex. That sliding point there, as you can see, just that latter point where it slides. So that encounters a considerable amount of flex, which would explain why it can actually fatigue and break down here. Here the hands are just roughly fitted for the time being, essentially just to check the operation, which as you can see the seconds hand is running. I'm going to leave that on a little bit of a time lapse so that we can see that everything works, the minutes and the hour recording. So here we can see the Seiko running on the left hand side with the seconds hand, minute recorder hand and hour recorder hand fitted to check the operation of all three. And keeping its company is a Poljot 3133, which I've been doing a little bit of tweaking on. This one is actually waiting for a service in its own right, but it's just had a little bit of tweaking so that I can actually give it a test wear at the moment. And that's one of my own that's been sitting in a drawer for some time. So I thought a good opportunity to put the both of them on test, and they can keep each other company as they're spinning around. And this is a time lapse that was shot at 1 frame per 4 seconds, sorry. So this is 1 frame every 4 seconds. It was actually shot at 1 frame every 2 seconds, and then it's been speeded up accordingly, and primarily to pass the time more quickly with regards to showing the hour hand moving. And as you can see, the hour hand is indeed rotating as it should, and this test is completed by stopping and resetting the chronograph to make sure that all of the hands reset back to 0 position, and then it's going to be left overnight to make sure that it doesn't run meanwhile with the chronograph stopped, and then I can reassemble the rest of it. So thank you for watching, and I hope you've enjoyed.